Hello everyone. Today we're going to talk about bubble sorting. Bubble sorting is one of the the simplest algorithm to sort numbers or keys that you have in an array. So we have these two arrays, array A and B, and we're going to see that how bubble sort works for these numbers. So it started with array A. Here on the right side, we have the pseudocode for this bubble sort. So we have for I equal to 0 to n minus 1, for j equal to 0 to n minus I minus 1, then we are doing a check or comparison between item at location j and its adjacent item at location j plus 1. So if a at location j is greater than a at location j plus 1, then we are swapping these numbers. Okay, so the inner for loop, okay, inner nested for loop, it's for doing the comparison between a number and all its neighbors, okay, until put them in its location place. And the first loop that we have for I equal to 0 to n minus 1, this is we are doing for all n numbers that we have. Okay, so for all n numbers that we have, we are doing this operation that is the comparison. So let's go see that how the bubble sort works on array A. So first of all, let's say that I is equal to 0 and j is equal to also 1. So j is equal to 0 and a at location j is equal to 7, and a at location j plus 1 is 3. And as you see, 7 is greater than 3, so we need to swap a at location j and a at location j plus 1. So we will have number 3, 7, 2 and 9, 4 and 8 also there at their location. So I'm going to write these numbers with the different color, so you see that they have been swapped. Okay, so we have 3, 7, 2, 9, 4, now 8. So now we are increasing j, so j becomes, let's write it with the color blue. So j becomes 1, but I is still 0. So now we are comparing the a at location 1, that is number 7 now, with a at location j plus 1, that is equal to 2. So if we comparison, so 7 is greater than 2. Again, if you are swapping the numbers at this location, so 7 and 2 will be swapped with each other. So what happens is we'll have these numbers here swapped. So 7 is 2 goes here, and we have number 7 here. And now again we are going back to for loop, okay, and increasing j. So j becomes 2, and now we are comparing 7 with 9, and because 7, okay, is not bigger than 9, so there's no swapping, and then we are just simply increase j, and j becomes 3. Okay, and here I forgot to mention that n is the number of items that we have in array. So in array A, because we have 6 numbers, so n is equal to 6. Okay, so let's write it somewhere here. So n is equal to 6. Okay, and j should go to n minus I minus 1. Okay, so n is 6, I is 0, so it's gonna be n minus 1 gonna be 5. So j can go up to number 5. So j is equal to 3. Now we have number 9, so we are now comparing with number 4. Okay, so j at location 3 is 9, and now we are comparing with number 4. And because 9 is greater than number 4, so we are doing the swapping. So now I'm gonna swap the number at location 3 and 4. So here we have 4, and here I have number 9. Now I'm increasing j, so j, sorry about that, so j now becomes 4, and now what I'm going to do is I'm going to compare a location 5 and location 4 and a location 5. That is comparing 9 and 8, and because 9 is greater than 8, so I'm swapping 9 and 8. So here I have 8, and number 9. So the first loop is done, okay, so the first iteration is done. So at the end, I put the number 9 at its location. So that's the property of the bubble sort, that at every iteration of like internal iteration that you have here, so you are putting the largest number, okay, to the very right of the array that you have, okay. So also it's we put the largest number to the right because we had this comparison. If the comparison was a of j less than a j plus 1, then we had the smallest number at the very right. Okay, so it depends that how you are writing like the bubble sort, but that's like the structure, the general structure. So number 9 now it's at the location, and that's why here we have n minus I, okay, because after each iteration we don't need to compare the number with the numbers that we already sorted, okay. So number 9 it's a location, so we don't need to go like to the end of the array. Now let's go here and change I, and now I becomes 1, and let's change the color. So I becomes 1, and now again we are starting with j equal to 0. But j now goes until n minus I minus 1, that is 6 minus 1 minus 1, that is gonna be 4. Okay, so we are not comparing these like these numbers with these numbers because 9 is as already its location. So here we have number, let's also get rid of these numbers that we have here. Okay. So here we have number 3 and number 2, and because 3 is bigger than 2, we are doing the swapping. So let's swap number 2 and 3. So 2 and 3. So also let's write these numbers here. 3 was bigger than 2. When j becomes 1, we have number 3 compared with number 7, and number 3 is not bigger than 7, so we are not doing any swapping. J becomes 2. Now we have number 7 in number 4. And because number 4 is less than number 7, so we are doing the swapping. So here we have number 4 and 7. Now J is 3, and we are comparing number 7 with number 8. And because 7 is not less than 8, okay, then we are not doing the comparison, okay. And also here we reach the end of the for loop, okay, because this is up to the n minus I minus 1, not this number, but n minus I minus 1, that's like the biggest number, that biggest index, like we are gonna like compare up to that number, not that number itself. So now we have numbers 8 also at its location. So number 8 is also sorted. So we have part of the array sorted. Now we are gonna change the I. So now I becomes 2, and here j will go to like up to the n minus I minus 1, that here I is 2, so j will go up to number 3, but not 3 is in itself included. So here let's compare 2 is less than let's get rid of these numbers. So we have 2 that is not greater than 3, so we are not doing any changes. Number 3 also is not greater than 4, so no changes. And number 4 is also not bigger than number 7, so we are not doing any changes, and we are done with this part of this iteration. So now we have number 7 that is already also sorted. Now I becomes 3, so we have I becomes 3, and let's also delete this one. So I becomes 3, and now j is equal to 0, okay. And as you see, that's I, okay. We are increasing I because we are gonna like do these for all numbers that we have. So we're gonna n times we are doing these operations to put n numbers that we have on its location. So when I was 0, we put the largest number to the right. When I became 1, we put the second largest number at its location. Then, like the similar to what we said, it's gonna like continue. So now j is equal to 0. So 2 is not less than 3, so no changes. J is equal to 1, so it means that 3 is not less than 4. And also we are good because now we are not comparing 4 with number 7. Okay. So here also 4 is at its location. Now we only have number 2 and 3, so I becomes 3, and we have only these comparison here. That 2 is not less than 3, so 3 is sorted as in location. Sorry about that. And also number 2 that it's at its location. So we have numbers 2, 3, 4, 7, 8, and 9 that is sorted. So that's how we can use the bubble sort for sorting an array. Now let's see that how we can sort the arrays at sort the numbers of array B. Okay, so here let's write also I equal to 0 and j is equal to 0 for array B. Numbers are 1, 2, so a allocation or like array allocation j is 1, and is 1 is not greater than 2, so we are not doing any comparison. So 1 is not bigger than 2, then j becomes 1, and we are not doing sorry about that. It is 2 not less than 3. J becomes 2, and we have 3 not less than 4. J becomes 3, and 4 is not less than 5. Okay, is greater than 5. J becomes 4, and 5 is not greater than 6. Okay, so we don't have these any changes, and there's no swapping. So as already you see that here on the first iteration we don't have any swapping. So it's obvious that if also we continue like working on like doing iteration, there will be no swapping. So when the array is already sorted, this might be like in intuition that we might be able like to optimize the bubble sort. And that's how we can like sort of like somehow optimize the bubble sort with this check. In that is in if in an iteration that we have on the bubble sort, there is no swapping that happening, okay, that's happening, then you can see that the array is already sorted. That's how we have in array B. In array B we have 1, 2, 3, 4, 5, 6. These are our numbers, and we didn't have any swapping here. So we can conclude that okay, array is already sorted. So here to the bubble sort we can have this that let's if I'm gonna like to add this thing here first. So if we have this one, then swapping, then we have, for example, some boolean value that if we have swap, we are putting equal to true. If okay, the swapping not happening, okay, if not swapped, okay, then okay, exit the for loop. Okay, exit the for loop. So this means that the array is already sorted. Okay, so that's why I provided this example of array B here to show that how we can optimize the bubble sort. So like we are going to continue on how we can see what's going to be the time complexity of the bubble sort. Okay, now we're going to talk about the time complexity of bubble sort. So the bubble sort at the best case can be from the big O notation of n. Okay, so the best case big O n. and that's when the array is already sorted. So if we have an array like array B here that is already sorted, then the time complexity of the bubble sort will be big O of n. And the reason is that you are because also we have this we add this optimization to the bubble sort, so we have only the outside, like the iteration only happening once. So in we have one that goes from j equal to 0 to n minus I minus 1, that I is also 0, so it's going to be n minus 1. So together it's going to be big O notation of n. Okay, so because our array is already sorted, and we can conclude that there is no swapping happen, so we are exiting the for loops. So that's why we have the base case of n, that is an array that is already sorted. Okay, so an array that is already sorted, okay, will give us the base case of n. And now you may also ask that what's going to be the worst case. So the worst case is that we have an array ordered but in a reverse order. Okay, so if we have another array, let's say C, and we have 6, 5, 4, 3, 2, and 1, then the time complexity of sorting these numbers using the bubble sort will be big O notation of n squared. Okay, as you see here, we have to select to move number 6 all here to the right side. Then we need to swap move number 5 here, the number 4 goes here, and number 3 goes here, and number 2 goes here, and then also number 1 that goes to the very left. So together we need to do like n squared. So we are not exiting the for loops because we have a reverse format for the we have a reverse numbers. And also in an average case, also it's going to be from the big O notation of n squared. And the reason here, this the first for loop, okay, it goes from 0 to n minus 1. Okay, at the worst, like the average case, we'll have some numbers between 0 and n minus 1, and also the second for loop that also goes from 0 to somehow again a number between 0 and n. Okay, so together the average case is gonna be multiplying these numbers together, gonna be big O of n squared. So that's the time complexity of the bubble sort that is at the best case big O of n, and average and worst case gonna be big O notation of n squared. One other thing about bubble sort is that bubble sort is stable. Okay, let's say we have another array C here with numbers 1, 1, 2, 2, 3, and 4. So also I wrote some like letters below each number. So let's say that we have a pair of key value here. So we have the key 1 and the value A, key 1 and the value B, okay, and also the rest. So here we are going to see that if we sort numbers using bubble sort, can we also keep the order in a way that because A now has come before B, so also can we save the order or not? If you look at the the bubble sort here, we are doing the swapping when A at location J or array location J is greater than A or the array location J plus 1. So doing having this condition on the in bubble sort, it means that if we have numbers appeared first at A then B, with both numbers like here we have A 1 and 1, the order will be kept. So after sorting these numbers, still we have A 1 with the key or the value with value A, then value B with the key 1, 2 with the value C, and 2 with value D, and also rest. Okay, and here, but we are just caring about these two numbers here and also these two numbers here. So it's like as we said, sorting algorithm is stable if it doesn't change the order how the numbers appeared in the array, okay, when the numbers are same. So here we have number 1, here we have number 1 with the two values a and b, okay, but after even sorting, the orders is not hasn't been changed. So 1 with a here and 1 with b here. So the bubble sort is a stable sorting algorithm.